Hello students, I am Sonali Kelkar from City International School, and today we are going to do the revision on the chapter Human Eye and the Colorful World. So let's start with the revision. So let's do this question. The first one, MCQ. When the white light enters a prism, it gets split into its constituent color, right? This is due to the different refractive index for the different wavelength of each color, or each color has same velocity in the prism. This is absolutely wrong. We know that the colors have different velocity, right? Red has the maximum velocity and violet has the minimum velocity. Prism material have high density, but that doesn't constitute the reason. Scattering of light, no. So the first one is the appropriate one. Different refractive index for different wavelength of each color. When we allow a white light to pass through the prism, due to the different constituent colors of white light, that is because the white light is made up of different colors of light. Because of different colors of light, they travel they travel with a different speed in a prism. As soon as the white light enters into the prism, the different components of the color travels with a different speed, right? So that is the main reason, and because of that there is a splitting of light, which is nothing but the dispersion of light, right? So the first answer is the appropriate one. Dispersion takes place because refractive index of the material of prism is different for different wavelength, right? Because of the refractive index, because the refractive index is different, so they deviate from the incident ray differently. Let me draw and explain you. Here, if I allow a white light to pass through the prism, this is a triangular prism, right? Okay, the white light is constituent of 7 colors, and all these 7 colors travel with the same speed in the air, that is 3 into 10 to the power 8 meter per second, right? But as soon as this light this light enters in the prism, there will be a deviation of different colors of light, right? There will be a deviation of different colors of light, right? And the less deviated color is red, and the most deviated color is violet, right? And the rest of the colors will fall over here. Okay, violet, indigo, red, blue, green, yellow, orange, right? So Vibgyor is going to form over here, and because of this we can see there is a deviation of different colors of light. This is the main reason why we can see the spectrum. Now coming to the question number 2, the air layer of atmosphere whose temperature is less than the hot layer behaves as optically. Optically, definitely the hot layer, because it is a hot layer, it will form the upper part of the atmosphere. The lower layer, which is a colder layer, which will be definitely denser, right? The colder layer is denser layer. It will form the lower part of the atmosphere. The hot layer is going to form the upper part of the atmosphere, right? As we know that when air gets hotter, it become less denser and it goes up, right? So it becomes less denser and goes up, while the air which is cooler, it becomes more denser and it settles down, right? So the right answer is denser medium. Now let's see the explanation. The cold air layer of the atmosphere act as an optically denser medium than hot air because the molecules are closely packed together, right? Because we know that when the molecules are closely packed together, they become more denser. The space between the molecule is less, so it becomes more denser, right? And cold layer, definitely the cooler air layer will have a denser particles, okay, and that's why it settles down and behaves like a denser medium. Coming to the next question, refraction of light by Earth's atmosphere due to variation in air density is called, because there is a refraction of light and that is taking place in atmosphere, so definitely it will be atmospheric refraction, The answer D is the right answer. Explanation: this phenomena is called atmospheric refraction. Why there is a refraction? Because the different layers of air, they act uh, differently. That is, their refractive index are different. Because of that, there is a refraction of air. The deflection of light by minute particles and molecules of the atmosphere in all directions is called dash of light. I will show you the diagram and you can then find out the answer. If I allow a light ray to pass through and strike on the particle, what will happen? These light ray will get deflected or in different directions. They get deflected in different direction, and by looking at the picture itself you can say this is nothing but the scattering of light, right? So the right answer is B. Okay, the said phenomena is called the scattering of light. Now coming to the question number 5. One cannot see through the fog because, let's see the options. Refractive index of the fog is very high. Light suffers total reflection at droplets. Fog absorbs light. Light is scattered by droplets. The right answer is the D one. The light is scattered by the droplets, right? Let me explain you this. We see that in fog, let's take, there are millions and millions of particles, okay? I'll just take one row of particles, right? When a light strike on the first particle, it will get scattered, right? It will get scattered in different direction, and then into the next particle again it will get scattered, then next again it will get scattered, again it will get scattered, but it gets scattered, and while scattering it is losing its intensity. While scattering, it is losing its intensity. So by the time it comes to the last point, it has total lost its intensity, right? And because of that, you cannot see the light, okay? Because the light is scattered completely. So the D is the right answer. Objects are not visible through the fog because droplets scatter the light rays completely. Coming to the next question, a prism ABC with BC as base is placed in different orientations. A narrow beam of white light is incident on the prism as shown in the figure. In which of the following cases, after dispersion, the third color from the top corresponds to the color of the sky? Now here, let's see what is the color of the sky. Blue. That means blue should come on the third position. This should come on the third position, right? Now, let us draw a normal prism. When I draw a normal prism and I allow a ray of light passing through the prism, during this I can see the dispersion is the top. At the top you will see the red light, and at the bottom you will see the violet. So violet, indigo, blue, green, yellow, orange and red, right? So if you see, the position of blue is third last position. It is the third last position. Here this is not the correct one, right? So of course if I reverse the position, let's see, when I reverse the position, and let me reverse the orientation of the prism also, and when I allow a light passing through this prism, what I will observe is red is at the bottom, right? And let's start from violet, indigo, blue, green, yellow, orange and red. So over here now blue is at the top third position, right? So definitely the orientation of the prism should be like this. So B is the right answer, where the prism is oriented or placed invertedly. Now at noon the sun appears white, okay, as what should be the reason? As the light is least scattered? No. all the colors of the white light are scattered away? Yes. Blue colors is scattered the most? No. Red colors is scattered the most? No. The right answer is B. Now let's see the explanation. At noon, the sun is at the top and the light rays coming from the sun have to travel less distance. Hence, all the colors get scattered away, very less, that is the blue and the violet color has scattered very less. Okay, now if I draw a picture and explain you, this is an atmosphere, the sun is right at the top of our head, right? There can be 2 and 3 explanation for this question over here, because they have given this reason, so this is the appropriate reason, which says that all the lights which is traveling through the atmosphere scattered away. So when the light rays are falling right at the top, okay, so the atmospheric distance that the light ray has to travel is the least. So atmosphere over here is the least. This is the least atmospheric distance it has to travel, right? And all the lights, all the different components of the white light, they get scattered, right? And because they get scattered, you can able to see the white light. See children, if a light, okay, if a light strike a water droplet, this is a water droplet, H2O droplet, right? Strike the light, strike a water droplet, it completely gets scattered, and when it completely gets scattered into different colors on all these different colors, that is your VIBGYOR, they form white color, right? When they get scattered, definitely the arrangement is forming a white color. So ultimately you are getting a white color. Okay, so because all the light gets scattered away by the particles, they get white. We got white color. This is one of the reasons. The second reason, if you see very carefully, these rays are nothing but normal to the atmosphere. So minimum refraction is taking place. Minimum refraction. Minimum refraction of light. Okay. Due to this reason also we see only white light, because hardly there is any change in the component of light, right? Other than this, other than the minimum refraction, the third reason is because there is a minimum refraction, right? Because there is a minimum refraction, there is least dispersion. There is least dispersion or splitting of light. Okay, and even you must have observed that when we allow a light to fall on the prism, this light ray is inclined. It is not coming from the top, right? It is inclined. So when the light ray is inclined, due to this inclination, the maximum dispersion is possible. So the 3 reasons are here right in front of you. Okay, now come to the next question. Question number 8. Twinkling of the star is due to the atmospheric. Twinkling of the star is due to the atmospheric dispersion of light by water droplets. No. Refraction of light by different layers of varying refractive indices. Okay. Scattering of light by dust particle. No. Internal reflection of light by cloud. No. So appropriate answer is B, right? The twinkling of the star is due to the atmospheric refraction, right? Now what is this atmospheric refraction? We know that our atmosphere, so if this is earth, right? This is our earth. It is made up of, it is covered with the blanket of atmosphere. We know that, right? And these atmosphere have different layers. These atmosphere have different layers, right? And each layer has different density, because we know that the hotter layer makes the top layer which has less optical density. Okay, so the top layer is less optical denser medium, and the innermost layer is more more optical denser medium, right? This is optically rarer medium, this is optically denser medium. Or okay, so you can use interchange the words. The top layer is optical rarer medium and the other layers are optical denser medium. Because the light has to travel through the different mediums, the light doesn't travel in a straight line, it bends towards normal. So every time when the light is traveling, it is bending towards the normal. So light is traveling in a zigzag manner, right? And we know that this is air, so air is not a stable matter, it moves around also, right? So due to the movements of the air layer and due to the different refractive indices of the layer of air, there is a continuous atmospheric refraction in the light, right? And because of that, when a person is looking at the sky and looking at the star in the sky, right, the light sometimes falls right on the eye. Let me draw an eye over here. Light sometimes falls right on the eye. Sometimes the light is falling behind and sometimes the light is falling ahead of the person. So the same intensity of the light is not falling on the eye. Because of that, the stars appears like twinkling. Sometimes it is very bright and sometimes it looks very dull. And this dullness and brightness, it is making the appearance of twinkling of star. So this is the correct reason behind this phenomena, right? Coming to the next question. The clear sky appears blue because blue light gets absorbed in the atmosphere. No. Ultraviolet radiations are absorbed in the atmosphere. No. Violet and blue lights get scattered more than lights of all other colors of the atmosphere. Perfect. So this is the right answer, right? Colors of all other, light of all other colors is scatter more than the violet and blue color light by the atmosphere. No, this is also not the right reason. So the perfect reason is the C one. Now let me explain you this phenomena, right? So when a light is entering from the sun, when the white light is entering in the atmosphere, right? So what happens? In the upper layer of atmosphere, you will find more amount of nitrogen and oxygen molecules. Okay, nitrogen molecules and oxygen molecules, right? And we know that nitrogen and oxygen molecules are, are, are very small. Okay, the size is very small particles, right? So these small particles can able to scatter the light of the small wavelength, right? A light which is having a very small wavelength, okay, and we know the spectra of the light which has very small wavelength, that is VIB. That's it. Violet, indigo and blue. This particular spectra of light has small wavelength, whereas yellow, orange, red, they have bigger wavelength. The red has the longest wavelength, right? Longest wavelength. Red has the longest wavelength, right? So these small particles doesn't make any difference. When they strike to these particles, it doesn't make any difference. They don't get scattered by these small particles. Okay, so the spectrum of the light which gets scattered by the small particle is violet, indigo and blue. Now, why can't we see the color of sky violet? Because the violet light is very less. Okay, in that spectrum of white light, violet band is very less. Okay, so that's why we cannot see violet color. This is one of the reason. The other reason is our eyes are not that sensitive to violet color. We are more sensitive, our eyes are more sensitive to blue color. So that's why we can able to see the blue color. Now the indigo and the blue color, it gets scattered most. Okay, indigo and blue color, it gets scattered most, and when you try this experiment, indigo and blue color getting scattered, so ultimate color coming out by the scattering of indigo and blue is only blue, right? You can do this experiment, children, at home. You can take a beaker, glass beaker, put a water in it, right? And you can take a torch, allow a light of a torch to pass through the beaker. Now after some time, so put some milk in it. Milk, and when you put some milk, stir this solution, right? And then you observe the color of the light. Okay, slowly you will see there is a shifting of the color of light from white towards blue, right? Initially when you pass light through water, it doesn't show any color, but after you mix milk in that water, you will see there is a shift in the color. You will see the color of the light is blue, right? And this is because the blue light gets scattered by the particles of milk. In this experiment over here in the atmosphere, nitrogen and oxygen, these particles can able to scatter the violet, indigo, blue light maximum, and the rest of the rays which is coming to our eyes, they are unscattered. Okay, so you cannot see the other colors, whereas you can see the color of the sky blue. Okay, so this is what the explanation I have done. You can read this explanation by yourself and then copy down in your copy. Right. Coming to the question number 10, the danger signal installed at the top of tall buildings are red in color. These can be easily seen from a distance because among all other color, the red light, we know that the red light has the maximum wavelength, right? The red light has a maximum wavelength. So the small particles are not going to scatter the light. The small particles which are present in air not going to scatter the light. So minimum scattering of the white light, the minimum scattering of the red light is going to take place. Because of this, our eyes can catch the red light. Clear? That is the reason. So the red light has a longer wavelength, so least scattered by the smoke or the fog. So what should be the right answer? The B one. Okay. Coming to the short questions and answers. Okay, let's read the question number 1. How will you use two identical prisms so that a narrow beam of white light incident on one prism emerges out of the second prism as a white light? This experiment, children, was initially done by Isaac Newton, right? So what he did, he put one prism as usual, and he made a beam of a white light to strike on the surface of the prism. Due to the refraction, the white light bends towards the normal, right? You can draw the normal right here, and you can see the white light is bending towards the normal, right? And he got 7 different colors which are the components of white light. And then what he did, he put one more prism, but this time he put the prism in a inverted manner, right? So he kept one more prism inversely, and what he observed that these light rays, they again recombined and they emerged out from the other surface of the prism as a white light. Okay, so these two prisms are doing two different functions. The first prism is doing dispersion of light. Here you can write down dispersion. Dispersion of white light is done in the first prism due to the dispersion, or we can say the spreading of the white light. Okay, we get the 7 different components of white light. And when I put another prism over here, so the phenomena taking place is recombination. Okay, so due to the recombination of the light, I am getting a white light at the end on the screen. Okay, so you can write down the answer which I have mentioned here, and you have to draw this diagram. You have to mention the dispersion and recombination done by the 2 different prisms. Coming to the next question, draw any Draw a ray diagram showing the dispersion through a prism when a narrow beam of a white light is incident on one of its refracting surfaces. Also indicate the order of the colors of the spectrum obtained, right? So you can show this prism, okay? Draw this prism, name the prism A, B, C or P, Q, R, right? Then you can allow a white light passing through a splitted cardboard, right? There is a gap in the cardboard and you allow a beam of a light passing through this cardboard and it is falling inclinedly on the surface of the prism, right? When it falls inclinedly, you can see there is a splitting of the different constituent of the white light, right? And when you put a screen over here, you will find that this white light has split it into 7 different color, right? So you have to, and you should be very careful. The V is coming down: violet, indigo, blue, green, yellow, orange, red. Red is the least deviated light because it has a long wavelength, and the second reason because it has a great speed. The velocity of the red light is more. Okay, something which is if some object is coming very fast, it hardly deviates from its path, right? A fast train running on the track, it hardly deviates from the track. Okay, whenever you want to make turn, okay, whenever you want to deviate from your path, you have to slow down your speed. Okay, so the slowest speed uh, is a violet color light, which has the slowest speed, so it deviated most, and the highest speed is red color light, has a higher speed, so it deviated least. This is one of the reason. The other reason, red has a greater wavelength, so it deviated less, and violet has the smallest wavelength, so it deviated most. So two reasons are there. Looking, okay, long questions and answers. Now here you can look. A beam of white light falling on a glass prism gets split up into 7 colors marked 1 to 7 as shown in the diagram. A student makes the following statements about the spectrum observed on the screen. Okay. Let's see the first part of the question. The colors at positions marked 3 and 5 are similar to the color of the sky. Okay, so 3 should be blue, and the color of the gold metal, 5 should be the gold metal. Color of the gold metal, I'll just write gold over here, which is yellow in color, right? So 3 should be blue and 5 should be yellow in color. As similar, okay, respectively, is the above statement made by the student correct or incorrect? Okay, justify. So let's see. Now we can write here 7 stand for Vibgyor, violet, indigo, blue, green, yellow, orange and red. Okay, now the student has marked 3 color as blue. Where is the color 3? No, 3 is yellow and 5 is blue, so he has marked wrongly. So he was wrong. Okay, now which two positions correspond closely to the colors of a brinjal? Now what is the color of the brinjal? It's violet color, so here 7th is the position of the color of the brinjal, and danger or the stop signal, that is the first. So first should be the position of the red signal, right? The signal stop. So 1, this is red, okay, and the 7th one, this is violet. So violet, okay. So brinjal color is violet and the stop signal light is red in color. The position is first. So here is the answer. You can go to the answer and write down in your copy. Now question number 2, draw a ray diagram to explain the term angle of deviation, right? So angle of a deviation, as we can see in the diagram, angle of the deviation is the angle between the incident ray when produced backward and the emergent ray when produced backwards, right? incident ray when produced forward and the emergent ray when produced backward. So this is our angle of deviation, right? When I produce this emergent ray backward and the incident ray forward, they are going to meet over here, and the angle between the incident ray and the emergent ray is nothing but the angle of deviation. So you have to draw the diagram and you have to show it. Why do the component colors of incident light, white light, split into the spectrum while passing through a glass prism? Okay, explain. So I have explained it many a times. I'll just read the question answer and explain you one more time. Draw a label ray diagram to show the formation of rainbow. This is also important. The diagrams are given in your book. You can copy down the diagrams. All the diagrams are important. Now coming to the B part of the answer. When a beam of light enters a prism, it gets refracted and splits into its 7 constituent color. This splitting of light ray occurs because of the different angles of bending of each color, because the colors are bent at different angle with respect to the incident ray. That is also you can write. Hence, each color passing through the prism bends at different angles with respect to the incident beam. So this gives rise to the formation of colored spectrum, right? And this is the diagram C, which is given in your book, right? Here you can see the splitting of light coming from the sun, okay? And due to this is a spatial phenomena. This is a dispersion of a light which takes place during the rainy season, and you can also see from a fountain or from a waterfall also. But there are 2 conditions necessary for the formation of rainbow. First of all, the sun must be behind the observer. This is the sun should be behind the observer, right? And these water droplets, right, are present, there should be a presence of water droplet in the atmosphere. Now how does this occur? When a white light falls in this water droplet, this water droplet acts like a prism. There is a dispersion of light. You can see the dispersion of light. So at point B, there are 2 things happening here. This is a refraction, the first one, and the second is dispersion, right? So 2 phenomena are happening at point B, and at point C there is a reflection of light. Children, in your book they have given reflection of light. You can also say total internal reflection. But the total internal reflection you have probably in your 11th grade. So due to the reflection of light, this light passes again internally, okay, and then it passes from the denser medium to the rarer medium. This is the denser medium water to the rarer medium, okay. Again there will be a refraction of light taking place at point D, right? And due to this, observer can able to see the 7 different colors of the white light. Coming to the question number 3, what is atmospheric refraction? And use this phenomena to explain the following natural events: twinkling of star, advanced sunrise and delayed sunset, and draw the diagram to illustrate your answers. We know that what is refraction of light. See, refraction of light is caused due to the earth atmosphere, which is gradually changing. Okay, why it is changing? Why there is a change in the earth atmosphere? Because there is different layers of air. Okay, the top layer is optically rarer medium and the bottom layer is optically denser medium. So due to the change in refractive indices of the different layers of atmosphere, there will be a refraction of light. Because it is caused by the atmosphere, we call it atmospheric refraction. Very simple, right? Now, twinkling of stars, I've already explained you about the twinkling of stars. So the hot layers of air at a high altitude behaves as an optically rarer medium for the light ray, whereas the cold layers of air near the Earth's surface behave as an optically denser medium of the light ray. So when the light rays passes through the various layers of the atmosphere, they will get deviated and bent towards the normal. As a result, the apparent position of the star is slightly different from its actual position. Thus, the stars appear slightly higher than the actual position in the sky. And due to this, the fluctuation in the position of the stars occurs continuously due to the changing amount of light that entering the eyes, right? So this is how the star twinkles, because the position is not fixed, right? Sometimes, let's take this is the original position of the star. Sometimes the star appears like over here, sometimes this appears like this due to the atmospheric refraction, right? And the light which is supposed to come straight from the star, it doesn't come straight, but it comes in a zigzag manner, right? And it falls on eye, right? It falls on eye in a very zigzag manner, and but our brain is not going to interpret the position of the star exactly. So what our brain does, it will just take this ray backward and it will probably see the star at this position, or it might see the star at this position, right? So the position of the star is changing, and there is a fluctuation of the intensity of light also, and due to the fluctuation of intensity of the light, the star appears brighter sometimes and sometimes it will appear dull. So this brightness and dullness contribute towards the twinkling of stars. Now, advanced sunrise and delay sunset is again the example of atmospheric refraction. The phenomena which is taking place in this case is atmospheric refraction, right? So, light which is this sun, the actual position of the sun is here, but it appears raised. Children, all the celestial objects, if you see any celestial objects standing on the earth, you will find their position is raised up because of the atmospheric refraction, right? Because of the atmospheric refraction, the light will bend towards the normal, because every time it is passing from the rarer medium towards the denser medium, and because of that, the apparent position of the celestial object will be the raised one, right? So before the sun rises, you can see the sun in the sky, and what is the time? 2 minutes before, right? And here the sun has already set, but just because of the atmospheric refraction, you can able to see the sun even 2 minutes more, right? So altogether the sun is 4 minutes more in the sky because of atmospheric refraction. So here, children, we have done the dispersion of light, and the rainbow is the phenomena which is the rainbow is formed due to the dispersion of light. Then twinkling of stars, advanced sunrise and delay sunset, and the apparent position of the stars have changed. This is due to the atmospheric refraction, and due to the scattering of the light, the sky looks blue in the normal daytime, and it looks reddish during the early morning and the sunrise or the sunset time, right? So all this phenomena is very important for you to learn, for you to understand, and this is the end of the chapter. I want you to write all the question answers in your portfolio, students, and practice to this chapter. Thank you so much.